PUSopen is a single C library implementing CCSDS and ECSS PUS communication protocols. It's a simple and cost-efficient solution. The library itself is for free. You just need to register, download, and you'll be all set to start integrating it. On top of the library, we offer tutorials, videos, examples, trainings, and the engineering services. Those services on top are indeed optional, and it all depends on your budget. So far, the project teams used PUSopen for the onboard software as a prototyping tool and as a test bench tool. Although it's rather small, the solution itself has been developed since the beginning with the quality in mind, so it was developed according to ECSS software standards, and we have used other industry standards to make sure that the quality is at the level where it should be for the space systems. Project PUSopen started back in 2018, and since then it has been used in the stratospheric flight test program with the Slovak Association for Space Activities. The team from EPFL in Switzerland has used PUSopen in the mission CHESS as a sort of prototyping software and also on their test bench. We had nice cooperation with Swedish company Unibot that integrated PUSopen into their space cloud solution on the IX5 computer, and in June 2021 that integration has been tested in orbit. It was a mission called Wild Ride organized by D-Orbit. All the in-orbit operations went well, so PUSopen has a space heritage. We even helped ESA to test their implementation of CCSDS 124 compression algorithm on the Wild Ride mission. PUSopen was generating housekeeping telemetry, and CCSDS 124 was used to compress that housekeeping telemetry and then decompress it on the ground. The project started with the idea of picking parts of the existing space communication standards from ESA and NASA and combine it into a single solution that would fit small-size market. PUSopen is portable to many different platforms. You can use it on top of the platforms that don't use any operating system, as well as those that are using operating systems or even real-time operating systems. We try to make everything around PUSopen simple. The library itself is for free, so you can just register on our website, you can download it and start integrating it with your code. We didn't want it to make it a solution that you will download from the website and then bye-bye, you will never hear from us. We want to be with you all the way, resolving any of your integration questions, any of your testing questions, the best way how to integrate it into your architecture and so on. And then on top of that, we can review your solution or even help you to extend PUSopen specifically for your mission. What is inside PUSopen? All the layers that you can see here on the slide, the encoding and security, virtual channel, space packet protocol, and then PUS services on top, that's all implemented in a single C library that you can connect on one side to your data bus or radio or any sort of like transmission equipment or your test bench, and then on the other side on top you can connect it to your user application code. And then on top of that, to make the PUSopen a solution instead of just simple library that you download from the web, we offer training and support. We offer some tools to help you configure PUSopen. We offer the documentation and then also resources like tutorials, videos, and examples that you can use out of the box to speed up your integration. There are 5 layers in PUSopen. It's configurable. You don't need to use all of them. You can select which ones will you have. So you can only use PUS services if you configure it like that, or you can use PUS services with a space packet protocol if you configure it like that, or you can use it as a whole stack. It's up to you. How do you want to tweak PUSopen for your specific application? So which layers do we have? At the very bottom we have encoding and security, which is the link layer of the CCSDS. So that's where we encode your packets and the transfer frames, and basically we give you a byte stream or bit stream that you can directly forward to the radio. Then we have a virtual channels implemented, which is a mechanism defined by both CCSDS and ECSS standards, and you can imagine them as a sort of parallel pipes, and you can assign priorities to those pipes. So let's say pipe 0 might be used for highest priority messages like alerts when your batteries in a satellite are running low, and when you want to prioritize that message even in the middle of downlink of, let's say, imaging data, you can use that pipe. You can put the message there, and it will be basically prioritized. It will be downlinked in the byte stream here, even in the middle of the image downlink, and then on the ground you can again get that message separated from the image downlink, and you can get it as soon as possible. The subnetwork layer sits here in the middle, and that's the point where you can connect PUSopen to your onboard data buses. So if you want to use PUSopen for the communication between the subsystems on board of your satellite, you don't need to go through the virtual channels or encoding layer. You can stay on the level of space packet protocol or PUS services and then send the raw space packets between your systems. The space packet protocol here, second from the top, can be used either with the PUS services or it can be used without them. So you can put basically any user data into the space packets and then send them through the virtual channels down, or then receive them in the other direction. And then on top of these 4 layers, which are mainly defined by the CCSDS, we have PUS services defined by ECSS. And we haven't implemented all of those services. We have picked the subset of the services that you can see here. We have a service 1, 3, 5, 8, 13, and 17. You just need to look into the standard what those services are. But the PUSopen is extensible to any services that you will need specifically for your mission. If you will see that you need more of those basic services defined by the ECSS, then just contact us and we can talk how to implement it for you. PUSopen internally doesn't have any active behavior. So whenever you want to do something, you need to kick it. So if you want to activate it or initialize it, you will need to call specific service. If you want it to produce a packet or the frame, you will need to kick it. And the same thing, if you will receive the data, you will store them in the buffer of the PUSopen, then you need to kick it again. Here we have the data, please parse them and notify our user application when you are done. We choose not to implement any active internal behavior because it's very difficult to make it in a generic way covering different scenarios of different missions. And on top of that, we believe that it's very good to save some power, save some CPU cycles whenever it's possible, especially in the space systems. PUSopen works on many different platforms. It's very portable. It's a very basic C code. We have already ported it on Intel, on ARM, on MSP 430, on RISC-V architectures. We've tried on top of the for the prototyping on top of the Windows and Linux, of course, but we also tried on top of the real-time operating systems like Artemis or FreeRTOS. And then if you want to use PUSopen for prototyping of your application or as a tool in your test bench, we have extension or the adaptation layers for C, C++, C#, and Java. Although PUSopen is rather simple and small, it took us a lot of time to develop it because we wanted to make it reliable, so it can be used both on the test bench, in the ground station, but also on board of the satellite, so it needs to be really, really reliable. We've used, as I said, the ECSS software standard, ECSS EST40C, and also the MISRA for coding. Just for illustration, you can see here the full documentation tree that we produced for PUSopen. So we started at the beginning of the project with the development plan, with the configuration definition, with the software product assurance plan. We had a full set of software and system specification and the interface documents. And then we continued with the design level documents and of course the full set of the VNV plans, VNV specifications, and VNV reports. The solution is based on more than 200 software and system requirements, and we had over 500 test cases. And as I said on the previous slide, it has been tested both on the development level, on ground, and in space. What is unique about PUSopen is that if you will work with some bigger companies, They will probably require some sort of quality assurance or product assurance documentation. We can provide you with a whole set of the documents regarding the quality of PUSopen, and we will also tell you how exactly PUSopen complies to the standards from ESA and NASA. The typical flow that you can use to adopt PUSopen solution is to start with sort of demos. So you can download PUSopen, try it for your applications, see whether it has the features that you need, and then please try to contact us. We can have focused workshop where we will try to understand your particular project, your particular mission. We will try to advise the best way of integrating PUSopen into your solution. We can have a review of the architecture. Basically, we can be as involved as you want. We can do prototyping together with you, and the only thing, as I said, that we charge for is the paid support. So that's the support, that's the engineering hours. You can choose how many do you want, how much do you want us to be involved in your mission. Indeed, if you have a larger team, you can provide a training and then also support for any questions you may have during the integration and during your actual mission. Here at the beginning, the teams are often using PUSopen for prototyping their space application, even for the onboard software. And in the later stages, the PUSopen is used either on the test bench as a supporting test tool, or then as a onboard communication library. We started 12Gs back in 2018 with a simple idea to create a place where people like to work and where the customers like to return. We're a rather small company. To date, we've contributed to 4 different missions. We have customers in Sweden and within the European region. And our core business is the documentation and the process improvement. We are also consulting in software reliability, and then we're developing the software for the small sub-market, so that's our PUSopen product. We have a previous experience from the space and aerospace industry, and also from the other regulated industries, so we know how to work with the standard, how to do software quality assurance, how to make sure that your solution will work. So what to do next? You can either download PUSopen from our website and start using it as is. Some teams prefer to work alone, to prefer not to reveal what is happening in their project, and that's perfectly okay. If you want to have more information about PUSopen, or you have some integration questions, do not hesitate to contact us on either through the email or just call us on the phone. We'll be happy to answer whatever questions you have. The first thing that we recommend is to contact us. We can have a free talk to understand your requirements, to understand your mission, even if it is not very well defined, even if you are in the initial stage. That is okay. That is the usual time when the teams are contacting us. They are selecting which tools, which libraries to work with, so we are used to that. Please contact us. We will try to answer all of your questions that you may have around PUSopen and how well it will fit into your solution. And at this point, we're looking forward to hear from you.